last time we talked about correlation, finding the correlation coefficient between two sets of variables. And in this class, we want them to be linear. So to check to see if they're linear, we can do a scatter plot. They kind of follow the linear pattern. And then if we want like a numerical value for how linear it is, we can find R, which is the correlation coefficient. And so R is usually going to be a decimal. It's either positive or negative. The closer positive one it is, the closer the line is to being a positive correlation, a perfect linear positive correlation. If it's close to negative one, it would just then be a negative correlation. What we don't want is for R to be close to 0. We don't want a really small R. Okay, so assuming that it is fairly linear, we can go ahead and draw a line through those points on your scatter plot, kind of approximating what they're doing. That's called the least squares regression line, the best one that we could possibly get. And there's formulas for them, but we're just going to let the calculator do all of the work. And again, it's just going to be the same process that we used to find R. So we did this problem before with the size of the house and selling price. Those ones are going to be pretty closely related. Somebody changed my numbers, so let me fix So once you've got all of your x values in L1 and your y values in L2, you can go ahead and run the program. Remember, size is our x because that's kind of what we know ahead of time. Our selling price is our y because that's what we're trying to predict. So we'll put x and y into our L1 and L2. Once we get to that point, we'll go to stat calc, and then we'll go down to number 4 for linear regression. Hit enter. If you have a newer calculator, it'll ask you what your X list is, that's L1, and what your Y list is, and that's L2. And then when you hit enter, you should get this screen up here. It's the same screen we had when we found R across the bottom, that's 0.901, we did that last time. But now we're going to actually be using the A and the B. So we didn't do this last time, did we? This example? Okay. So let me write out, because some people, when they get this on the test, they try to make it a little bit harder than it needs to be. So what you're going to have for your least squares regression line, technically there's supposed to be a hat above the y, but if you don't put the hat on it, I don't really care. So it should be ax plus b. They tell you that at the very, very top of your calculator. It's the first line underneath of it, y equals ax plus b. What we're going to do is we're going to plug in values for the a and the b, and that's it. So this, this y and this x, you're going to leave as variables when you type in the equation of the line. So those are going to stay letters. You're not going to put any numbers in for them. Don't plug in a 0. Don't try to solve for anything. Just leave them as letters. So the y hat is still just going to stay a y hat. The thing that we are going to change is the a and the b, and they'll tell us on the screen what our a and our b are. So if you look over here, a is 0.099. 0.099. That's just from the screen. And then don't forget to leave your x right there. Plus, and then our b is 160.194. And then that's your equation of the line. So for part A, that's your equation of the line. Don't do anything else with it. You can't add these two things together because they're not like terms. This one has an x, this one doesn't. Don't put in a 0 over here and try to solve it for x or anything like that. Just leave it like that. That's your answer. Don't do any more steps. Don't make it harder than it needs to. Yeah, it is. Okay, so on your notes, the A and the B are the switch. That's because I took this screenshot from a different book. So this is switched. That's just because they do it So if you go down to, instead of doing number 4, when you do your stack calc, if you go down to number 8, it does linear regression as well. You'll still get your r and your r squared, but your a and your b are going to be switched because they write it differently. They put a plus bx. They put the x at the end instead of after the first term, so they just write it differently. That's why these 2 things are going to be listed like that on your notes. So I never updated that. Not Then your A and your B are backwards. Yes, thanks for reminding me. Okay, so like I said, on the test, that's all you need to do. Don't do anything more with it. Don't make it harder than it needs to be. Just write it out, put in your A and your B, and then just leave it like that. Once you get to part B, that's the place where you actually do need to plug some stuff in. So they tell you to predict the selling price of a house of size 2,800 square feet. So if you're predicting something, you're going to be using the least squares regression line to predict what it is. They tell you the size of the house is 2,800 square feet. The size of the house is our x value. So this right here is going to be our x, 2,800. Whenever they have these types of problems, if they give you a value, it's always going to be your x, and you'll just plug it in for your x. And the reason is we're always trying to predict what y is. If we know what y is ahead of time, we don't really need to use the least squares regression line. So it wouldn't be, you want to sell a house for this much money, what size should it be? Because you don't really have any control over how big the house is that you have. So anyway, so for all of these, you'll just plug it in for x and then put it in your calculator. You don't have to do any algebra to solve these things. So for part B, we have the x is 2,800. So we're just going to plug it into our formula. Y hat equals 0.099 times 2,800 plus 160.194. Or 37.4. That's my Y hat, so it's going to be approximately $337,000 based on this one. And then part C is a little bit different. It says draw the least squares regression line on the scatter diagram of the data. So we already talked about how to do the scatter diagram. You just have to put this into L1, L2, set your stat plot to scatter plot, and then do zoom 9. But now we need to put the least squares regression line along with the scatter diagram. So the way you can do that is listed out here in part B. What you're going to do is, if you go to y equals, this button right here, so don't hit second first to get to the stat plot, just hit y equals, and we've got different equations we could possibly put in. This is somebody else's. So what I'm going to do under y equals, I'm going to type that equation up there that I had for my least squares regression line, so 0.099 is what I'm starting with. And then I'm going to type an x. So your x is going to be this variable button right here that's in between your alpha and your stat. So if you put this here, that's your xt, theta, and n. That's the button you'll use for your variable. And then plus 160.